I think under food section of drawdown, we talked about perennial staple trees. Those are still considered here. Willow, maple, eucalyptus, and so on, which can provide biomass for bioenergy. We are specifically going to revisit here perennial bioenergy crops. So land use in this perennial biomass is ranked at number 51. 3.33 gigatons in reduced CO2 by 2050. Net cost upfront is $77.9 billion, with net savings estimated at $541.9 billion. So here is an example, miscanthus. It's often called elephant grass because it grows so tall, growing to 10 feet tall in a single season. This farmer in his field at harvest time. So obviously there are perennials. That means you just do what is often called coppicing. So you chop it close to the ground and they can grow back. I just picked up the list of few of these things from the US study which looked at switchgrass, miscanthus, reed canary grass, alfalfa, Bermuda grass, Napier grass, eastern gamma grass, prairie cordgrass, and pasture on marginal land, on the conservation reservation program land, low input high diversity prairie, where prairie is basically temperate regions, grassland and shrubland and so on. So there again I'm mentioning willow, poplar and eucalyptus as trees that can provide biomass, but here focusing more specifically on bioenergy. Of course, corn can be perennial, sugarcane is perennial, but these are food grains or food crops which often raise issues about food security versus diverting these crops for ethanol and other additives to fossil fuels, which can create problems for poor people. So it's a very short story, but essentially it is argued here that the perennial bioenergy crops are a important part of the solution, and they provide the feedstock for biomass energy generation, making those emissions reductions possible. So they also can generate their own climate impact of 3.3 gigatons of carbon dioxide by 2050 as they replace annual feedstocks and sequester more soil carbon. So the main direct impact of perennials is, of course, that you don't have to uproot them each year and replant them. So the soil disturbances are reduced, soil carbon sequestration increases, exposure of the soil carbon to the atmospheric loss processes decreases, microbial life gets better, the carbon sequestration goes deeper, and so on and so forth that we talked about before. Our analysis assumes a rise from 0.5 million acres currently to 143 million acres by 2050. The cultivation of perennials is costlier than annuals, but returns over 30 years could be $542 billion. So there is a mental model of farmers to think short term, so incentivizing long-term thinking, especially returns over 30 years, can be a challenge. So that is something that has to be dealt with for many aspects of climate solutions, of course, including switching to smaller cars or hybrid cars or electric cars, or just driving less, flying less, eating less meat. Everything requires incentivizing, and that's part of the problem here as well. But nonetheless, perennial bioenergy crops are something that are a good no-regret solution to be included in drawdown.